so the characteristic curves are also similar. Several effects determine this curve, and you can mark the distinctive points. The problem with this motor is its low starting torque. With a simple trick, you can provide a starting boost. Add another bigger capacitor in series to the auxiliary winding. Due to the overheating, this starting capacitor must be switched off at a certain speed by a centrifugal switch. Once the induction motor has reached its nominal range, it can maintain its nominal speed quite well, even with a varying load. That's because the torque curve is deepest at the nominal point. Please also watch our video about three-phase induction motors. To change the sense of rotation of the motor, the current direction within the auxiliary winding must be reversed.
Okay, before we proceed with that, because this one is much related with your lab, okay? Apa jenis sikit ni? Okay, so kita ada line, kita ada neutral, and auxiliary winding. So kita ada auxiliary winding and capacitor. Line and neutral. This one is the main winding. This one is the auxiliary winding. Okay, so this one is your induction, one phase induction motor. Sini dia punya motor kan, one phase. Ordinarily, if we didn't put any capacitor here, okay, this is the performance of your motor. No capacitor, okay. The issue is here. Okay, sorry, put up. This one is top. This one is stick. Okay. If you remember, kita ada slip kan? Kita ada slip. Saya terbalikkan graf dia sebab reference tu dia buat macam tu. So kalau speed adalah 0 to 1500. So kalau slip dia akan jadi 0, 1, and your 2% 2 to 8%. So ini 100%. Ini adalah 6. Okay. So with no capacitor, usually kita set the operation dekat sini lah. Your T load, okay. T load, okay. With that, when there's no capacitor and we need an initial load here, then it cannot give you the load torque that you required to be. Okay, sini kosong ni, load kosong. Yang ni maybe 2 Nm. This one is 5 Nm. Tak nombor, so tak boleh nampak. Okay, so at starting kan dia ada issue, very hard to start the rotor. The rotor needs external force to be rotated. Okay. So then, what we do is kita letak, we place a capacitor here, and now the characteristic of your one-phase induction motor will become like this. Kita panggil dia running capacitor. Okay, so when we have a running capacitor, there you go. There's some torque that can hold on the rotor. Okay, depends lah. Depends on the value of this capacitor. Okay. And now, issue yang ni ada torque. Mana gambar dia? Ada torque. Yes. Okay. There's a torque. However, maybe this torque is not enough for the operation. Okay. Kalau tak cukup, what can you do is you add one more in parallel with the first capacitor, which is called starting capacitor. This one is running. Okay. Bila starting, yang hijau this one is C start plus C running. Okay. There's another issue pula. So bila kita letak C starting ni, saya buat jarak sikit lah. Okay. Tengok there's a difference. Tengok kat sini. So when you place the starting and running capacitor here, so this one is C start plus C run on the circuit. This is the new graph. Okay. So basically, you can increase the starting torque. Remember sini, yang the one that touch the paksi torque ni adalah T start. Kan? Yang ni T start 3, yang ni T start 1, yang ni T start 0. Starting torque yang first without capacitor, starting torque yang second with running capacitor, yang ketiga with starting and running capacitor. Okay. The starting torque and yang ni adalah maximum torque. So it has a different level lah, sama macam starting. Okay. Issue dia, we wanted to run the motor according to the application that we wanted to operate. Okay. Untuk case yang ni, now, let's say motor tu sepatutnya it should hold 5 Nm. Okay, settle. The motor already can grab 5 Nm or give 5 Nm untuk load tu. However, tengok dekat belah sini pula. Okay, take a look at here. This one is the nominal speed yang sepatutnya motor tu running. Let's say dia 15, mungkin dekat sini 1430 lah. Nominal speed dia yang sepatutnya motor tu operate. However, bila you pakai yang ni, okay, now this point akan dekat sini. Betul? So tak cukup, it's not enough. Now your speed become 1300. Not enough. Okay, so what we do is kita letak this switch so that we can disconnect this starting capacitor and dia akan pergi kepada desired speed yang we nak. Okay, jadi macam ni. Mula-mula kita akan connect. Okay, and then your motor will run ikut karakteristik ni. Okay, until, sebab kita nak yang ni je, nak starting je. Okay, until the speed become 70 to 80% of full load. Okay, now kita disconnect dia. So when we disconnect this circuit, hanya tinggal yang ni je lah, this one on the left. Now, bila disconnect, C running. Dia akan continue the characteristic following the blue one ni, the C running. And now you have your 1450 back. Okay, and this switch ni dia automatically disconnect lah. Dia akan baca motor speed and when it reach 70 to 80%, dia akan disconnect. Okay, why do I emphasize this thing? Because during your lab, what actually you do is you are just tackling this part. Okay, we didn't do this. Okay, task yang last kali, section D. Okay, what are you doing is you are varying this value. Okay, kita nak tengok. Okay, we wanted to see with the variant of C, dia akan dapat curve yang macam mana? Ataupun adakah dia macam tu? Itu conclusion that I wanted to see on your report. Okay. Okay. Lagi satu. Since your lab you are using 3-phase. Okay. So the 3-phase sebenarnya adalah, let's say you are connecting with delta. Okay. And that running capacitor is in between here. Kan? So ni ada, let's say R, Y, D. So now you only have V and R. L, N. Nampak tak the relationship? Dia seolah-olah yang ni tak ada. Okay? Salah satu winding tu you disablekan bila you letak capacitor. Okay. Let's continue.
Very similar to the function of a 3-phase motor, so the characteristic curves are also similar. Several effects determine this curve, and you can mark the distinctive points. The problem with this motor is its low starting torque. With a simple trick, you can provide a starting boost. Add another bigger capacitor in series to the auxiliary winding. Due to the overheating, this starting capacitor must be switched off at a certain speed by a centrifugal switch. Once the induction motor has reached its nominal range, it can maintain its nominal speed quite well, even with a varying load. That's because the torque curve is deep.
Nominal speed though. This one is your speed. The one that I mentioned. Okay?
To change the sense of rotation of the motor, the current direction within the auxiliary winding must be reversed. If the manufacturer offers an AC motor with a 6-pin motor terminal board, you have a very easy task to change the sense of rotation.
Okay. For one phase, sebenarnya, how to reverse the direction of your motor? Let's say this is your motor, one phase, right? This is your L, this is your neutral. So this one is just one phase winding of your motor, right? And for our lecture, kita hanya tambah another auxiliary winding. This one is the main winding connected to the power line, and there's another auxiliary winding
worse. If the manufacturer offers an AC motor with a 6-pin motor terminal board, you have a very easy task to change the sense of rotation. Just replace the metal jumpers as indicated by the diagram. All values refer to rated operation. In rated operation, an induction motor has the best ratio of efficiency to power factor. The slip in rated operation is approximately between 3 and 7%. This motor has a nominal speed of 1400 RPM. With this information, you can evaluate the synchronous rotational speed of the RMF.
Okay, sama macam three-phase, it also has its own nameplates, and the information of the nameplate will help you on deciding what kind of motor that you wanted to use. Okay, so here is, you can see the synchronous speed, the slip through. Dia tak split, tak nampak kot. Ni adalah nominal speed. Okay, dia tak bagi pun kot ini. Dia bagi nominal speed, and from nominal speed you can find the rated, the synchronous speed. And you can sort of find the mechanical power that the motor can give you, and also the torque. Okay, this one is some hint on selecting the right capacitor value for starting here and running. Okay.
The reason is that the size of the capacitor depends on the motor power and the winding ratio of the working auxiliary. The capacitor power on the motor plate is the mechanical output power. The nominal torque can be calculated with a known equation. There exists a rule of thumb to determine the run capacitor. The capacity is between 30 microfarads and 50 microfarads per kilowatt of motor power. As you can see, this is a very rough estimate. The reason is that the size of the capacitor depends on the motor power and the winding ratio of the working auxiliary winding.
Don't forget, if you choose a capacitor value for your lab, don't forget to check whether the value is available on the market or not. Okay? Kalau tak, you buat kerja short sendiri lah. Okay.
Thus, it is very difficult to determine the capacitance. It is best to contact the manufacturer. The starter capacitor, if it exists, is about 3 times as big as the run capacitor. The rated input power or electrical power can now be determined by a simple equation. The efficiency is a simple ratio. The insulation class describes the thermal tolerance of the motor winding.
This is some extra information for you. The insulation class is on the nameplate. The class is classified by how much heat that the motor can bear. Okay, so kalau class H, dia boleh tahan 180 degrees. So kalau more than 180 degrees, baru dia meltdown. Motor pun meltdown, yang orang ni.
The letter indicates the motor winding's ability to withstand operating temperatures for a specific length of time. The code IP, or ingress protection, defines how well an enclosure protects against the external environment. As the number gets higher, the protection gets better. The first digit defines the protection level against solids, the second against liquids. You must use both digits to define an enclosure. Further,
Ni yang kat luar ni. So macam kalau if you are using the motor for drilling, kan, when you drill, bukan you lah, when the technician drill the land or the buildings, kan dia ada residual yang akan memantul-mantul tu kan. So itu yang protection against solid tu. So kalau you are using for just food processing, yang terpercik tu liquid je, air kan. So nak kena cari yang ni, yang kat luar ni, yang tadi, yang value ni kena tinggi. Kalau nak untuk marine punya purpose, nak submerge the motor tu, kena cari yang tinggi untuk liquid.
use both digits to define an enclosure.
This
Further information about your motor can be obtained from the data sheet. The capacitor motor can be classified as asynchronous, AC, and induction motor. It is a rather robust motor, but the weak point is the capacitor and the speed switch if you have a starting capacitor. Because electronics are becoming more and more powerful and cheap, big single-phase induction motors are replaced more and more by three-phase induction motors, controlled by VFD. You should know that small VFDs can be connected to single-phase voltage. For more information about electric motors, please visit our webpage. If you want to be updated about new...
Okay, settle. Next. Ini dah tahu kan? Dah kan? Dah, masa 3 phase pun ada kan? Okay. For induction motor untuk one phase, one phase lah. Kita panggil dia one phase. For 3 phase, kita classify dia by rotor. 3 phase squirrel cage or 3 phase wound. Ataupun wound tu dia ada another name for wound is slip ring. Itu klasifikasi dia. But for one phase, it's classified by the how you start the motor. Okay, there's 1, 2, 3, 4, 5. 5 method of starting, and this 5 method actually the representation of the motor type. Okay, and all these starting techniques are different according to dia punya cost and how much starting torque that the technique will give you with the same motor. Okay, in term of physical of motor, kita tak nampak sangat distinct difference between each of starting method. Okay, so secara fizikalnya tak nampak beza pun. Cuma one thing that you can differentiate between one phase and 3 phase is the existing of this capacitive punya box ni. Kalau nampak yang tu dia one phase lah. Okay, 3 phase kita tak letak capacitor sebab you can easily run your induction motor by just supplying a 3 phase supply. Okay, so we have kalau tengok sini pun tak tahu beza pun sebab dia dekat dalam the connection. Except for this one, shaded pole motor. Mau nampak lain. Okay, so we have resistance start. Why resistance? Sebab we need to vary voltage that need to supply. So the variant of voltage will vary the torque, right? Okay, capacitor type, this one, permanent this one, capacitor type and capacitor run. So 2 capacitor there, one is for starting and another one is for running. Okay, another thing that you can consider regarding auxiliary and apa saya dah tunjuk pasal lab? Dah kan? Yang warna biru ni. Okay, we have your rotor. This one is your winding. Okay. So this is the main winding. Your neutral, and this is your one phase supply. Let's say 230 volt. Okay. So from previous class, you already know that with this kind of configuration, your rotor will just going forward and backwards, and they just vibration here, right? With that, we need another winding, which is called an auxiliary winding. Connected together with your line, power line. Okay, dia connect sekali. Yang ni the green one is auxiliary, auxiliary winding. The blue one is the main winding. Okay, with the auxiliary winding, we have switch, which is called centrifugal switch. Okay, and when you wanted to place a starting or running capacitor, you can also put here on the auxiliary winding. Okay, now let's check the maximum or the synchronous speed dulu. Okay, originally for one phase biru je kan, the blue line je, one phase, right? So with one phase, by right, your biru lah, your synchronous speed or your maximum speed yang that motor can provide. Let's say the frequency is 50 Hz, the pole is 4. Okay, so 120 times 50 divided by 4 dapat berapa? Not 4, yeah. Pole. Sekarang ni with main winding, with main winding, the blue one, north south, so 1, 2, right? Okay, let's say I didn't open yet this auxiliary winding. Okay, kita left open dulu. So now your pole is 2. Okay, 1, 2. So it's 120 times 50 divided by 2 dapat berapa? 3000 RPM. Okay, you expect that this motor should give at least 29, right? 50 RPM. Betul? The motor speed. Okay, must be lower than synchronous speed, right? Okay, however, this one phase motor dengar ada sikit, so dia nak kena ada auxiliary winding. Okay, so with the auxiliary winding, you need to add another winding on the same line. Okay, but bila you tambah, when you add this winding, now your pole become 4. Yes, good. 1, 2, 3, 4. Okay, so now what's the rated speed? NS 120. We are talking. Kita tengah mengumpat motor yang sama ni. 120 kali 50 Hz divide by 4. And now how many? 1? 0. So maximum motor speed that you can use only 1.450, right? So it's lower than expectation. That's why kita ada switch ni. Kita on dia, okay, supaya at the beginning it will give you this high torque. Then after it reach 1300 RPM, it will open automatically. So when it open, it go back to the original setting, pakai main winding saja. Okay. Okay nah? Senang faham kan? Sebab tu, bila high torque, remember high torque, kita ada 4 winding, we have 4 winding, it will provide you high torque, right? But lower speed. However, if you are just using one winding, you can have high speed but no torque or lower torque. Okay, same motor, different behavior. Okay, next, okay, ini sama macam dalam video already mentioned. And in terms of construction, yes, it also has same rotor option, whether square cage or wound rotor. Baca lah nanti. Slot winding, nothing new. Okay, ini dia punya the real picture of your winding. Actually, kenapa dia letak title dia rotor? Yang ni dia punya rotor. This one is the stator. Alright, let's go for what is the distinct difference between 1 and 3 phase. Okay, starting torque dah banyak kali berbual mulut. For one phase, starting torque is very low as compared to 3-phase. Reliability is more reliable. Okay, why? Kita tengok next pula. Motor rotation. There's no mechanism to change the rotation. Maksud dia mechanism yang macam 3-phase lah. Okay, however, actually we can change the rotation by changing the capacitor location. Done. Alright, then where can be used for 1-phase ni? So 1-phase ni kalau tengok, dia lebih kepada low power. Blowers, vacuum, centrifugal pump, washing machine, grinder and compressor. But for 3-phase, more likely we can see it on the industrial, okay, and high power application. Commercial drives, since they are more rugged and economical in terms of operation efficiency. In long term, kalau you nak pakai yang lebih tahan lama, better ambil 3-phase. Sama macam nanti kalau perasan kan, if you are going go through housing residential yang already 10 or 15 years, okay, rumah yang dah 10 atau 15 tahun duduk, cuba tengok dia punya 3-phase, dia punya supply. Okay, sebab recently I pergi my sister house dekat Damansara, kota Damansara. So dekat dia punya terrace house tu, ada yang 3-phase, ada yang 1-phase. Okay, when the house has a 1-phase, tak ada kat sini, dekat luar lah, biasanya luar rumah. Bila rumah tu dia ada 1-phase punya setting, okay, actually you can request for the TMB to change rumah, your parents maybe kan, you can change the setting to 3-phase. Provided memang kapasiti penggunaan dalam rumah tu memang untuk power 3-phase. Okay, let's say the house is already using 3 aircon, ada 1 washing machine, peti ais, ada apa, deep freezer, ada banyak lah high power punya ni. Better you change to 3-phase. Sebab satu, in term of economy, dia sebenarnya lagi jimat. And reliability, dia lagi tahan lama as compared to 1-phase sebenarnya. Okay, power source, as the name imply, so 1-phase induction motor, 1-phase, 3-phase supply. Starting mechanism, 3-phase induction motor are easily self-starting rather than 1-phase, they are not self-starting. Next, apa tu? Efficiency dia low because only 1-phase that use. Kenapa? Apa masalah 1-phase? Bukan masalah 1-phase, masalah ni your auxiliary winding ni sebenarnya it cannot withstand a long operation. Sebab tu after a while, once it reach the speed yang mencukupi, you akan turn off. Kita tak nak dia run lama sebenarnya. It will damage the motor actually because of heating. Okay? Sebab asalnya motor ni kan 2 je. So kalau you add extra, you menambah, you add up the temperature on the motor winding, on the stator. Okay? And then cost, okay, dia 1-phase mestilah dia murah, cheaper because the construction is much simpler. Okay, and less winding compare dengan 3-phase, quite expensive. Slip, okay, yang ni kita akan belajar on our next equivalent circuit. There are 2 slip for 1-phase. Kalau motor 3-phase, kita ada 1 je, slip saja. Yang ni kita ada forward and backward slip for 1-phase. Okay, power factor low. The power factor for this 1-phase usually less than 0.8 or 0.8 something and above. And for 3-phase usually is 0.88 ni below 0.8 and below 1-phase. 3-phase usually higher than 1-phase. Okay, power factor yang cos theta tu. Repair and maintenance, easy to repair. Kalau you tengok dekat YouTube, bersepah-sepah all the orang share kan, how to open a washing machine, how to open a blower, lepas tu dia modify how to open standing fan, itu semua 1-phase, so it easily to troubleshoot and repair. But for 3-phase, dia susah because complexity of the stator winding and rotor. structure dia sama datang sekali dengan repair and maintenance. Dia simple and easy to manufacture, relevant and economical, murah. Jadi yang tu. And then more complicated for 3-phase to construct because of extra component involvement. Sebab kali 3 kan, leceh lah. Wah, pun kalau ada 3 susah juga kan. Seronok je lebih. Nak mengurus pun tak senang. Tadi kita tadi. We go for theory first. Okay, I will explain parallelly regarding this starting and running performance. Okay, untuk split phase dia ada satu jenis je. Apa yang being splitted is the phase. Okay, saya tak ada gambar tu kat sini. What you need to, yang ni biasa selalulah ditanya dalam teori. What is the method? What is the main method of starting industrial motor? So you can give this one actually. This is the answer. And this one, 1 marks, 0.5. And we usually ask for the explanation. The explanation of this one can be found here. So split phase tu macam mana? How can we build it? Okay. So what is split phase? Split phase winding, dia ada 2, dia macam sama macam yang lain. 2 stator winding, main and auxiliary, and set 90% apart. Dah tengok dalam video kan? It's already seen on the video. Along the stator and designed to be switched out of circuit yang saya terang tadi lah. Actually it's kind of split phase method. But when you have a capacitor on the phase, on the auxiliary winding, now we call it capacitor start motor. Kita dah masuk second type of starting. So back to split phase ni. What else? The important thing is auxiliary winding. Okay, kan? But tadi saya cakap bila kita tak nak auxiliary winding ni operate in a long time, we don't want it. Because the auxiliary winding is designed to have a higher resistance ratio than main. Okay, resistance dia higher than main. Okay, remember power loss. When resistance is higher, the power loss will be higher. So sebab tu kita tak nak, we don't want it to operate it in the long term. Then to ensure the current, and then we need to ensure current leads IA leads auxiliary to ensure current in auxiliary winding leads the current. Okay, IA must leads the main winding. Why? When its lead means it's higher, so that your rotor can rotate. Dia maksud dia ada phase shift lah bila lead ni. Maksudnya when you draw the phase diagram, this is your V. This is, let's say, your, dia lead ke lagging kan? Okay. Let's say this is your main winding. Your auxiliary must be phase IA, or in terms of waveform, let's say this is your current IM, lead ke depan. So your auxiliary winding, since it's bigger, and dia delay. Dia bukan delay, dia lagi advance daripada IM. Okay, and this, how to accomplish this? Using a small wire. Okay, tapi small wire, tapi high resistance. Sebab dia banyak turn. More turn, more torque. Okay. It used only for starting and does not have to take the full current continuously. Okay. And this one, okay, this one is how you check. Ini kalau design lah, is how you check whether main winding punya ratio is lower than the auxiliary winding. So you can check dia punya ratio. Ni dah tengok kan? From this video you can observe. Actually saya dah terang. Cuma kalau nak tengok dia it explain you in term of voltage and current.
It's a capacitor at the start. Further, some single-phase motors need a running capacitor too, which will operate throughout its running time. Good day to everyone. Today we will see why a single-phase induction motor needs a capacitor at the start. Further, some single-phase motors need a running capacitor too, which will operate throughout its running time. To start with, you will see a single-phase supply with 230 volts and a winding of an induction motor connected to it. Wave pattern of the supply voltage and the single-phase current shown on the graph here. Now what we need is to get the rotor of the motor to rotate like this when power supply is connected. Normally an induction motor has some induction load also acting on it, in addition to the resistive load on its windings. This inductive load makes its current curve to shift, with an angle related to the voltage curve. But here we have taken the condition where the motor is with pure resistive load only. It is for easy understanding, and this condition is when power factor is at 1. So you will see both voltage and current curves start at the same time with zero value and ends to a zero value also at the same time. Actually,
Azab dengan AI dia cakap. Okay, actually it will explain. Nanti tengoklah. Take your time to watch this at home because I ada target nak explain benda lain hari ni. And
with a single phase connection.
This video it shows this the magnetism happen for one phase and how it affect the speed and current of the stator sahaja. Okay, so tadi kita tengok in term of construction speed. Okay, and now you can see what is the effect for V and I. Okay, itu saja, tak ada apa interesting sangat pun. So kalau if the motor have more pole and now the rotor can easily grab the next winding that will have a strong magnetization in between. Okay. So let's go back to our slide. Okay, so I will go through characteristic dulu. This one, split phase. Tengok take a look. Main plus starting, and this is the top. Okay, and this is where you disconnect your switch. So that when you disconnect the switch, you have the right speed of that motor. Okay, let's go for capacitor start. The difference is here. Dia ada capacitor. Apa lagi different dia? Switch ada, tapi tak ada capacitor as compared to split phase. So capacitor start, dia ada switch and capacitor. This one. The different in terms of characteristic, it will give you higher torque. And same, it will turn, it will disconnected once it reach your desired, once it reach a certain speed, so that you can have your operation speed, the nominal speed that the motor should give. Okay. Now capacitor start, move forward. Okay, lagi satu you boleh tengok ni. How much torque that it can give you? It's 300%. This is the original. This one is the maximum torque that the configuration can give you. Next, permanent split capacitor motor. Apa yang tak ada? Switch tak ada. So when switch tak ada, now dia jadi macam ni, simple je. Dia tak ada dua rough. Okay. This motor have a lower starting torque as compared to both previous two method. Okay. At normal load, this motor are efficient and have higher power factor and smoother torque than ordinary one phase. Why? Because dia tak ada turn off, turn on punya switch tu. Dia tak ganggu torque. Okay. Next, capacitor start, capacitor run. So tadi ada capacitor, tak ada capacitor. Now you have two and you have switch. For this start, what is the benefit? The larger C is present only during starting, okay, to ensure IM and IA are roughly balanced. Okay, then the running capacitor must be running. Running capacitor must be large enough to balance the current at normal motor loads. Okay, current balancing ni isu dia apa? Isu dia akan relate dengan torque. Okay, when your current is not balanced, you will have a ripple torque on your. Let's say this is your torque. Okay. This is smooth torque. Habis-habis pun, it will have a small spike here, and it will smooth towards steady state, right? Steady state, right? Okay. But if the current is not balanced, what happens is you have this ripple. But dia punya ripple ni steady state, continuously ripple, but in a smaller. So ripple ni, we don't want this ripple. Ripple ni will cause heat. And if kalau torque ripple, physically what you can see, dia macam tersekat-sekat. Bukan stuck, dia macam stepper motor. Macam gegar. So dia tak cantik lah you punya application tu. Okay, so this one. For capacitor start and capacitor run, okay, since dia ada switch, mesti ada ni. And since dia ada dua, so dia ada, it will have two curve. Okay, so how much torque that this capacitor start and capacitor run can give? Up to 200% from the original setting. Okay, this one is permanent capacitor in this motor is typically about 10 to 20% of the starting capacitor. That's how you set. Ini kalau faham, can be used to select capacitor value on your lab. Okay. Alright. Okay, yang ni lain. This one is different because it is called a shaded stator pole. So what being shaded actually? Only one. Okay, winding ni satu saja. Dia tak ada auxiliary winding, tak ada. And it has a salient pole. Okay. Salient pole meaning that ni dekat construction dia tu, dia macam tu, ataupun macam kat gambar tu, macam ni. Macam ni. Salient ni dia macam menonjol sikit ni, salient. Okay, so that salient pole will be used to construct or to implement a shading coil. And this shading coil surrounded by short circuit coil called a shading coil, short circuit. So this one will help the starting of the motor. Okay. However, yang ni yang paling sekali lah.